Hi there. Good afternoon, everyone. My name is Tien-Yin Chou. I'm the Dean of the College of Construction and Development in the Fengyang University and also the Director of the GIS Research Center in Fengyang University. So this is the session by the Taiwan Space Union. They arranged Geospatial Information Technology. It's an online course. Today, this afternoon, I'm going to talk about the disaster management issue to all of you who are interested in getting some credit by this kind of smart city courses regarding to how we can apply some of the remote sensed technology and the most up-to-date technology in charge of the disaster management issue. So hopefully everyone will be able to get interest. So this is the second course from me. As I mentioned about, my name is Tien-Yin Chou from Fengyang University. So I'm going to talk to you this afternoon about several things. The first one is a nature disaster in Taiwan. As you know, Taiwan is comparatively a very small island. We have only 36,000 kilometers square. For the entire island, and there are so many different kinds of nature disasters. So I'll introduce, for example, the earthquake, the typhoon, the floods, and even the drought condition in Taiwan, which is we're facing that yearly. So I'm trying to introduce to you all about some of the nature disasters happened in Taiwan. And the second session is about the disaster prevention, which is very, very important issue in Taiwan. So how we can apply different kind of technology, different kind of GIS or remote sensing or some other technology. Like firstly, we have to apply the international standards because all the systems and all the sensors, even all the platform has to acquire the same kind of standards. So there are lots of different kinds of international standards. So I'll try to introduce to you some of the very basic ISO or some of the very basic Open Geospatial Consortium, OGC standards, which has been widely used in lots of disaster management issues nowadays. And also the IoT, the Internet of Things. This kind of Internet of Things together with artificial intelligence, we can say is AIoT. And so there are so many different kinds of hardware and software toward, for example, the earthquake or even some of the floods or the debris flow warning. And of course, it's really hard to predict the earthquake, but for floods or typhoon direction or some of the high-risk landslides area, so it's possible to get some very good pre-warning system, and how we can use artificial intelligence, how we can recognize what's happening now, and from previous land cover classification by most of the remote sensed images, and now to the pattern recognition by different kind of sensors. So I'm going to talk about during the session 2. And then the third session is about intelligent management. So it's a kind of integration, how we can use different kind of integrated system and very, very smart facilities to assist us in dealing with all this kind of issues regarding the disaster management. So that's about this afternoon session. And hopefully in the later, nearly 2 hours lecture, you'll be interested in finding how we can apply different kind of technology used toward the kind of disaster management. And also the assist of this program, he will give you very basic, just 2 easy quiz and also one of the questionnaires. So hopefully you'll be have good patience to listen to the entire session and also answer the quiz and also get some questionnaire feedback. So let us know what we can improve, or what is your real interest, or are you satisfied, or are you glad to heard about to hear about this afternoon's session. So this is the entire outline of my talk for this afternoon. So I'm going to, for the first session, some of the nature disaster in Taiwan. And also the session one is about some of nature disaster in Taiwan. So this is the graph. I think you can also see the graph on your screen now. So this is the typhoon. And as you can see, the typhoon invaded Taiwan from lots of different directions. So there are so many directions of typhoon coming to Taiwan each year. And as you can see by this graph, this is what happening in Taiwan in the past probably 10 to 15 years. We still have lots of this kind of floods problem in Taiwan. Even for the Taipei city, the entire subway was merged into the water many years ago. And also each year we suffer about the kind of floods, the kind of very heavy rainfall brought by those typhoons. So that's one of the very serious problems in Taiwan. So how we can apply a very up-to-date technology in dealing with this kind of nature disaster issue. So that's what I'm going to introduce to you this afternoon. So we have to analyze what caused this kind of problem in Taiwan, especially for a lot of those kind of metropolitan area. As you can see on your screen, you see some of the recorded rainfall event has over 170 millimeter per hour. Just in 1 hour, there are 117. This is now the highest one. As you can see, this one, 133. So it's the return period is nearly 500 years. While all the facility, all the construction, for example, inside the city, some of the dish is only designed as the return period for 10 years. And some of the major sewage system is only for 5 years or 25 years or even just for 2 years or 10 years. But most of the heavy rainfall all exceeds all the designed return period. So that's a problem because we cannot have this kind of excess water to able to be drained out in this very short period. And that's the major reason to cause the floods. So what can we do in dealing with this? We cannot always depend on the engineering method, like to build another wider channel or another drainage system. It costs too much, and also is not smart enough. So that's why we say resilient city. We say any kind of city, it has the capability of resilience, which means you cannot to be 100% from all this kind of trouble-free. No, it's nearly impossible. So in Taiwan, we do have debris flow disaster. We have floods, we have debris flow. Why we have debris flow? Because as I mentioned about, Taiwan has a 36,000 square meters of the entire area, but it's very steep, very steep. From the ocean side to the high peak, the high peak is 4,000 meters. The high peak is only about 150 kilometers. And then from the peak to the east side of the ocean is another 50 kilometers. So you can tell most of the water, most of the rainfall, as I mentioned about, although we have a very high average precipitation amount in the world, 2,600 millimeter. So it's very high even in the world, but we have too steep slope for most of the mountainside. So 3/4 of the entire island, we call it slopeland or high mountain area. So there's only 1/4, only 25% of the entire Taiwan's is, we say, flat land, or we say is below 100 elevation. So 100 meters elevation. So the recent climate change problem is also increase the frequency, intensity, and duration of extreme rainfall events very, very significantly. And in the year of 1999, there was a big earthquake. We say Chi-Kuei earthquake. The Richter scale is 7.3. That earthquake destroyed more than 60,000 houses and killed almost 3,000 people. So after that one, we still suffer by several typhoons. So each year we suffer by typhoon, and typhoon brought a lot of very, very extreme high rainfall in a very short period. So it brought a lot of this kind of debris flow. So debris flow has become one of the very, very high risk disasters in Taiwan. And also, this is the record from the Weather Bureau. Just in one day, we could have 50, you can feel it, the felt earthquakes from Richter scale 3.9 to Richter scale 5.4, just in one day. So this is a real record from Weather Bureau of Taiwan. And also we have 1,500 millimeter of precipitation just in 2 days. And just 2 years ago, we have 2 typhoons in 1 week. So as you can see, we suffer by typhoon, we suffer by earthquake. So we're facing those kind of things. And those are the natural disasters which will not be able to cope with completely. So what can we do? We have to know what's happening, we have to know how, and we have to apply a lot of very, very good high technology in this kind of issues. So if we look at the tectonic plates and faults near Taiwan, and also this is the record from the Weather Bureau in Taiwan, the Central Weather Bureau in Taiwan, from the year 1991 to 2016, we have more than 600,000 events of the earthquake, which can be felt or which can be recorded by those kind of facilities. So that's a seismicity in Taiwan. So that's a very, very serious one. And also, as you can see by this graph, from the year 2012 up to the year 2019, each year we suffer by 30,000 to 40,000 earthquake in Taiwan. And these are the epicenter of the earthquake. As you can see, this is Taiwan, and most of the earthquake happen on the East Ocean side, because that's the 2 plates just jump together. So as you can see, like just for the year 2020, we suffer by 2,300 of the earthquake events just in the year of 2020. So this is so many earthquakes happen in Taiwan, and lots of the earthquake has very, very high magnitude. The Richter scale is scaled from 1 up to, well, like last year, we have several earthquake is higher than 6, sometimes 6.1, 6.3. So, and also these are the spectrum by the seismicity being recorded. The spectrum has been changed in this one because after the September 21st, 1999, the Richter scale 7.3 earthquake, the Central Weather Bureau, they improved their facility to record and also to detect the very, very sensitive spectrum. So that's why we have a very, very high amount of activities after this one, because after the facility being built. So this is due to the change of the very good spectrum reflectance by the earthquake facilities. And as you can see, we still suffer by lots of earthquake every year in Taiwan. So the challenge of the kind of very, very short time, a very heavy rainfall, is because due to the climate change, all the precipitation or the very, very high rainfall amount in the very short time period has become no more things. And most of the designed, the drainage system is only have a return period for 5 year to 10 year or 25 year or up to 30 year. But the return period being recorded now sometimes over 100 year, over 500 year. So all the engineering methods, they all have some kind of limitation. We impossible to build another drainage system can cope with 500 years of the return period. So we need non-engineering technology, which means we need resilience. We need smart city to improve the disaster prevention efficiently. And also all this kind of information, it was very difficult to be collected and also to be understood or to be wisely used and pre-warning alert in real time. So that's why we need artificial intelligence. We need those kind of IoT facility. We need a lot of those kind of things. We need platform. We need some kind of API. And also we say the cloud IoT information communication, because up to date, there were like 5G, there are MBiot, there are Wi-Fi, there are LoRa, there are lots of different kind of communication technology nowadays. They can apply lots of these kind of things in different kind of dimensional things to display the technology, and it can achieve the target of the three-dimensional intelligent management. So the solution is to create a three-dimensional disaster reduction methodology by the smart cloud IoT system. So this is what I'm going to introduce to you this afternoon. So if we ask about 5W and 1H is what we can do, how we can detect the floods, and how we can detect the regional drainage water levels, and can we use different kind of facility, different kind of sensor to really record that, and how about the sewage, the sewer water level, if it's overflowing or not, and current status of the flooded images. Can we use some of the CCTV camera to really identify about the floods, identify about the event, and where has the flooding been occurred, and what we can do? Because if we need to know if during the typhoon season, some of the very high-risk bridge, if this bridge need to be shut down, or if this very high-risk roads has been suffered by the floods, has to be shut down. And when can we work together with the artificial intelligence system to predict the floods, to predict about some of the, even for the landslides? We know to predict the earthquake is really impossible now. We have not have the very good high technology nowadays, but for floods or for very high risk landslide area, we could have some kind of capability to make good prediction. And also the rainfall forecast, which is like in Taiwan, we can have the 6 hour, we can have 12 hour, even 24 hours for the rainfall forecasting. Because we can use a lot of different kind of satellite. We can use a lot of different kind of rain gauge. And there's so many very, very good model will be able to forecast the rainfall amount. But we have to do that in a real small scale, which means like before, We can do the rainfall forecasting for the entire island or for one city, but now we try to do that for just one village, for one very, very small administrative region. And also about water level rise, and also when will be overflow, and how to prepare before any kind of disaster happen. It's not only depend on those kind of facility, but also depend on, for example, the local volunteer for disaster prevention and how to deal with the disaster. And also, if a disaster really happened, how to recover after disaster. And also, who should be alerted, like the people in this area, the local resident or tourist, and how to publish the warning. Nowadays, there are so many different kind of warning system. Everyone bring his or her cell phone just with him or with her. So if we can use the cell broadcasting technique, or we need the app to send the kind of warning, or we can use the short message to send by the telecommunication company. That's all different kind of warning system. And how can the non-governmental organization communities can work together with the local community and to respond to this kind of disaster management. And also the disaster caused by the very short-term heavy rainfall, or because by the poor drainage in the side dish, or the external water support affect the internal water, and or because the entire topographic influence, because it's just too steep, or because the slope was too high. So for all those kind of reasons, the efficiency of developed of this, we say, three-dimensional disaster reduction of the smart cloud system in the metropolitan area. So that's the system I'm going to introduce to you, has been widely adopted in Taiwan, especially for those metropolitan area. So we say we have to have very smart monitoring. You have to use a lot of different kind of sensors. For example, the camera, the rain gauge, and some other very, very useful sensors, the water level sensors, or some other detection sensors. And all those sensors has to be very, very good, we say smart governors, because all these kind of sensors, we can use that as a scheduling or the contingency problem to prepare and also to respond. So we use those kind of sensors to prepare, to respond, or to recover. So how to use those kind of sensors can be really adopted as a very, very smart Internet of Things together. So that's the things I'm going to introduce to you this afternoon. So the session one is about the disaster prevention and why we try to follow the international standards. In Taiwan, the environmental monitoring things is one of the very, very major topic in Taiwan, because most of the area in Taiwan is very fragile and very sensitive. We have a very, very steep slope, and also, as I introduced to you, we have so many earthquakes, we have so many typhoons. So various equipment used to detect and monitor all kinds of environmental characteristics, because for different kind of risk, different kind of disaster, need different kind of monitoring device, different kind of interoperability device, different kind of integration platform. So the spatial information, the cloud computing, open data, big data, all those kind of technology is very, very useful for monitoring, for interoperability, for integration, because everyone has to talk to others. This is one of the example. We have a very, very urgent need for interoperability between different agencies in Taiwan. The local city government has to work together with the central city government, and all the different departments from the central government, they all have to work out together. This is one of the examples. For example, the Forest Bureau is supposed to manage or the elevation higher than 1,000 meters in Taiwan, which is forest area. Stormwater Conservation Bureau in charge of the slopeland, which means any land zone is higher than 100 meters elevation up to 1,000 is in charge by the Stormwater Conservation Bureau. And the water resource agencies is in charge the river basin. So the river itself and also the neighborhood of the river basin is in charge by the Water Resource Agency. And also the Central Geological Survey is in charge of all the high-risk geological places, the detection and also the investigation. These are the 4 different apartments, and it all belong to different ministry in Taiwan. So the only way they can all communicate well, because during the disaster happened, the disaster has no matter who is in charge of where. So all the different departments, they have to work out together. They have to communicate together in very fast time. And also they have to talk about so many things. So the administrative interface by the Forest Bureau, by the Stormwater Conservation Bureau, by the Water Resource Agent, or the maps, either by the shapefile, by the ArcGIS, or the geodatabase, or even by different kind of like an AutoCAD or different kind of standards by the OGC standard, WFS, WMS, or the sensors interface. There's so many different kind of sensors. There are rain gauge, there are camera, there are water level, there are geophone. And the publishing interface, there are so many different kind of interface. Each database, commercial database, they all publish by using their own publishing interface, the data logger, and lots of things. But all the facility, all the data, they have to speak in the same languages. So that's why we say the standards. So we say standards interoperability is one of the most important things. So that's why for the first session, I try to introduce to you about some of the international standards. So a great quantity of those kind of different kind of data from different departments, they have very, very low quality, but can we make everything more efficiently? We have to make a thin map. And to making this kind of thin map, it's just like things from the black box, because all the sensors data, the vector data, the satellite image, the aerial photos, everything, we have to go through international standards and is capable to create this kind of thin map. Only this kind of thin map will be able to analyze or will be able to understand what's happening now. So in Taiwan, the challenge is, can we cope with so many different agents, so many different graphs, so many different data sets? And can we use only one set of standards? So even there's a lot of various types of sensors, there are a lot of data communication. We have to communicate between the camera and also with the water level with the geophone. And everything, every sensor, every data have to talk about in the same languages. So the data format and the real-time requests and responses is really, really important. So the challenges in Taiwan in the past 20 years, the government spent a huge amount of the budget and also work on how we can work out together just by one integrated system, so we can deal with even for different kind of disaster. So we can have just one platform, because every sensor can work out. We use interoperability. So for example, this is one of the example in one of the county in Taiwan. So this county, we try to use a lot of different kind of sensors, and all the sensor can be recorded, and they can all be attributed. They're all sets of data, so everyone can check if everything is correct. Even for the pumping facility is already in the scheduled site before any kind of heavy rainfall being forecast. And all the map, you can use either the Google map or the kind of e-map, and what kind of preparation, like if the pumping area is correctly, and also we can use the cell phone to make sure all the preparation, everything is already on the site, everything is ready. So this is one of very, very good example in one of the county in Taiwan. So before any kind of typhoon will be invaded to Taiwan, like before that, so the entire county will be able to make good preparation for this event. So in Taiwan, there are lots of international standards being applied. And for specially related, we follow a lot of things, either by ISO or by the Open Geospatial Consortiums, like the Sensor Things API, like even for the Common Alert Protocol, and also by the OGC, the Sensor Web Enablement, the Sensor Things API, and lots of things. We can use, even for the indoor, we use the moving feature, or a lot of things, we can use the Common Alerting Platform, which means every data, all the sensor recorded information, we can exchange, we can analyze, we can understand each other just in real time. So it's an integrated data set for emergency response. So this is a very basic thing. In Taiwan, because the government suffered by a lot of different kind of very, very dangerous, high-risk disaster each year. So the government spent a huge amount of budget trying to build up this kind of very basic, we say the basic infrastructure. So all the sensors, they have to talk to each other. All the platform, they have to publish the map in the international standards. So the standard systems, to be making this kind of alert, in Taiwan, we do have a lot of this kind of experience. Like we work together with international standards, how we can publish the kind of flooding system in San Francisco area. Like they all have different kind of sensors, and how we can create the collaboration between so many different agencies in Taiwan and work on just one kind of standards. And even for the indoor one, or even for the three-dimensional model, because this kind of three-dimensional model is very useful for any metropolitan system to be analyzed or to work out together. So using this kind of prediction, using this kind of forecasting technology, there is a new word, it's a Geo AI. Because everything has a three-dimensional way. And artificial intelligence, we say AI. The Geo AI plus the Internet of Things plus the three-dimensional way. And also use the AR or the VR with the data cube. So these create a very, very complicated, a very sophisticated database management, and combined with different kind of algorithm, different kind of management system, and also include like machine learning or some other modeling interface and planning. So the core of the artificial intelligence nowadays can create a very good real-world application domain. So, but enabled to do this kind of very good core of AI, we need to put a lot of sensor. We need to put a lot of this kind of API, and all the governmental agency, they have to work out together. So in Taiwan, the public sector work out very good with academic and also with the private sectors in Taiwan, trying to produce that. So there are a lot of Internet of Things hardware and software has been developed in Taiwan. So for example, some of the customized equipment we can put in the field, like the camera, like the rain gauge, like the geophone, like the wind speed, wind direction, or even for the three-dimensional windshield detection, or the geophone. We can detect the energy changes, so we can really record about the vibration, even for the earthquake. And also, we can have a lot of this kind of training mode to be established. So for the training mode, we can learn by all these kind of sensors. And using all these kinds of sensors, we can use different kind of communication technique. The communication technique, we can use Wi-Fi, we can use Bluetooth, we can use the 3G, the 4G, we can use MBiot or any kind of like LoRa, all different kind of communication technology. Or even now, the SpaceX company, they have announced the Starlinks. The Starlinks has already been covered a lot of part in the world. So it's possible for any part of the world will be able to wisely use the Starlinks in the future. Enable everyone will be able to connect through the satellite communication. So there are so many different kind of communication nowadays is capable to be used by this kind of different kind of sensor. And all this kind of technology will be improved very, very fast. For example, like 10 years ago, or even 2 years ago, even some of the communication technique has been improved just by these very, very recent years. So in Taiwan, the Central Weather Bureau, they already built up almost 700 stations in nationwide. All this station is equipped with very, very good sensors to detect about the rain gauge, detect about the weather conditions. So they can forecast and even use the satellite. So they'll be able to forecast very, very good precipitation forecasting for the next 6 hours, 12 hours, 24 hours, or even for several days. So the forecasting technique has been improved a lot in Taiwan. And these are some of the equipment being used by the Central Weather Bureau. And they can use the local, as the 700, the local weather bureau station with the satellite systems work on together. So the SASCOM and the Earthworm, they can to receive the data, process the data, and also post the procession, and lots of things. And also in Taiwan, the Fengyang University been worked out with Southern Water Conservation Bureau almost 20 years ago. And up to now, we build up almost 100 this kind of station in the field. Either is by the mobile one, or it's by portable one, or it's just by the rain gauge. And all the rain gauge has a solar panel power, and also can reflect the real precipitation amount in the field in real time, or some kind of soil moisture about the soil water content. And also using the portable unit or the permanent station. So in Taiwan, there are lots of this kind of station has been built by the Southern Water Conservation Bureau and work together with Fengyang University. And these two trying to, even for this kind of mobile facility, we built up this kind of mobile facility many, many years ago. It can use a four-wheel truck to carry the entire facility to the field. And you can stay in the field, just operate everything by itself for 7 days. It's equipped with a power supply, equipped with a satellite communication, equipped with lots of different kind of communication. And there's camera, there's water, there's a rain gauge, and there's communication. There are wind speed, wind direction, lots of things. So it can catch and detect all the information directly on the field and sent back through the satellite communication. So it's equipped with the mobile facilities. And if you look at the screen, I would like to show you one of the debris flow being happened in Taiwan many years ago has been recorded. We can just check that. We can see that in real time in the office or from the cell phone. So this is the geophone. The geophone detect like 10 to 15 minutes ago in the upstream. The geophone detect the very abnormal frequency, which we say there was a very serious landslide from the upland about 15 minutes before. So this is after the 15 minutes. This is the real debris flow event. So this is one of the event, a very, very heavy debris flow happened in that riverside. So as you can see, the entire energy and also the velocity is very fast. So this is one of the things has been recorded. We have the complete facility. So we know exactly about the velocity, we know the volume, we know the speed, and we know the amount because we have put all different kinds of sensors in the upstream, in the middle stream, in the downstream. So this is how we learn about the mechanism of the debris flow. The reason for us to put the camera, to put the geophone, to put the sensor, to put the water level sensors, is we try to learn the mechanism of the debris flow so we can make a very good prediction next time. So I think several years later, we might be able to create a very, very good, because for the past 10 years, we have recorded about 20 to 30 like this kind of very, very heavy debris flow event for the past 10 years. And every data sets is already being recorded, not only by the image, but also the rainfall amount, and also the geophone, also the velocity, also the water level, the soil moisture changes, everything. So hopefully for the next 10 years, we'll be able to develop a very, very good debris flow like forecasting thing. But nowadays we can only use the geophone to make a pre-warning system. So debris flow monitoring system in Taiwan, we have created permanent monitoring station for about 23 permanent station. In Taiwan, it has been detected about more than 1,500 for the high risk debris flow Wild Creek. So we put only about 26 of that for the permanent station equipped with all the facility, with the camera, with soil moisture, with geophone, with water sensor, and rain gauge. So we also developed a kind of mobile station where several mobile stations can be carried by the four-wheel trucks to any field. And also the one person will be able to carry the portable unit up to the slope land. And also for the communication. Of course, everything is equipped with the satellite communication, but it's too expensive. And also the frequency is not too high. And also if they're LoRa, if they're MBiot, we can use LoRa. We can use MBiot. If they're ADSL, if they're Wi-Fi, we can use that. Or if they're 4G. But during the typhoon season, everything of this will be out, because even for all the station, it will be out. So it's only the satellite communication is the most reliable, because we have the power generator inside. So every site is equipped with a power generator. So it can provide the constantly power up to 5 days. And so as long as the power supplies, and then we can use the satellite communication. Everything can be sent, all the information to the emergency operating center. And it can wisely to display the platform or use the APP to making the alert. So this is the way will be able to do things very smartly. So that's the debris flow monitoring systems up to now in Taiwan. So all these kind of the instruments, all this kind of different kind of hardware. For example, we have the data center, we have the rain gauge, we have the camera, we have the geophone, the wire sensor, the soil moisture sensors, the meteorological sensor for the wind direction, humidity, the kind of the lots of different kind of things, and also the radar water level meters. So these are part of the sensors, and also the flow meter, the wire load cell, and also about the water pressure and the water level, the earth pressure cell, and also the GPS, the extensometer, and the tilt meter. So lots of these kind of sensors we put in different places and use different kind of sensor. But all the sensors, they have to be able to communicate with each other, because every sensor is being put, some is upstream, some is middle stream, some is downstream, and some is inside the river, some is outside the wild creek, and some is embedded into some kind of constructed engineering construction. So every sensor, they need to talk to each other, because if we need to know the whole environment, we can not only depend on the upstream one, we also need to have some kind of sensor from the middle stream, from the downstream. So the smart city, what we mean by the smart city, we have to use lots of different kind of sensor, not only from the upstream, but also in the city downtown. We need a rainfall station, we need a flood survey station, and we can decide if the ditch is not enough. We can decide if the capacity is not enough. So there will be floods. So then we can make some kind of good preparation. So okay, it's almost 50 minutes from now. So let's take a probably 10 minutes short break. You can take a look of these slides. I will just leave the monitor to these slides, and you can also take a rest. I will continue my lecture in 10 minutes. Thank you.
郑老师，谢谢你啊。
不客气啊，谢谢。
谢谢。
Good afternoon. So this is Tien-Yin Chou. I'm the Dean of the College of Construction and Development in the Fengyang University. I'm also the Director of the GIS Research Center in the Fengyang University. Welcome you to join the second part of this afternoon lecture about the disaster management. So I'm talking about how we can make a smart city. The smart city, we need to have lots of the artificial intelligent things and plus Internet of Things. Internet of Things require lots of different kind of hardware, software, and artificial intelligence means all the kind of hardware and software will be able to create, to analyze, to understand, and also to make some kind of published information very, very smartly, or we say by itself. So all the features, the most important thing is can make automatically report disaster response while receiving all this kind of warning, and also can make some kind of analysis and about the intelligent. So we say the artificial intelligent Internet of Things. So in the city, we can use different kind of communication. So there are lots of good benefit of this. The benefit is toward this kind of floods or toward this kind of extreme heavy rainfall in very short period. We can depend on the Weather Bureau forecasting. We can depend on lots of the local rain gauge and create a very, very good, we say, geostatistics information and make very, very good forecasting. And using those kind of forecasting, we can prepare a lot of different kinds of sensors, can be installed, and also can be analyzed. Use this kind of sensors, we'll be able to know where we need to open some of the gate, where we need to close it, where we can really we need to put some kind of warning system to the local citizen, or we need to shut down the roads or even shut down the bridge. So for all this kind of information, we can use by the rainfall gauge, by the image, by the floods on the road, and also how about the sewage system? If the sewage system has already been overflowed, do we need to install some kind of pumping system in advance? So this kind of system required a lot of Internet of Things sensor and a lot of the artificial intelligence technique. So this is what the GIS and remote sensing will be able to do. So the smart city require a lot of things by the GIS and also by the remote sensing. So the disaster prevention, I'm going to talk about artificial intelligence. How we can make the sensors being very, very smart. Traditionally, we have to read by our own eyes or by our own knowledge, or even all the scientists or the researchers, they have studied lots of reference, lots of information to be able to understand what's the meaning of any kind of device signal. But nowadays, we can use a lot of very, very good methodology, good algorithm has been fully developed. In the research field, there are lots of this kind of like CNN, RNN, those kind of technique, or even YOLO, you only look once. This kind of technique, just using this kind of technique, we'll be able to let all the sensor be really smart, because the sensor can learn even by itself. So use this kind of information, use this kind of algorithm, we'll be able to identify a lot of image. And those images might be from satellite image, might be from air photo, might be from the local camera, from the UAV. And also all this kind of image, we can mark and we can train. We can training. Because first of all, we have to let all the sensors know what's the meaning of this image. This image mean there are floods. This image means there's some kind of construction cracks. This image means it's bad. This image means it's good. So the image has to learn by itself. And learning this by 100, by 1,000, by 1 million, by 1 trillion, all the sensors will become smarter and smarter. And so we need to test the validation and then to develop some kind of automatic, or we say even for the automatic recognition module. If we put on the car, the autonomous vehicle nowadays is same kind of idea. It's still tracking a lot of things, it's still learning a lot of things. So it can make it self-learning things. And so that's why we say deep learning. So it's also one of the methodology. So it can establish some kind of report. So what we can do for the artificial intelligence, why the artificial intelligence can help. Like these are some of the previous things happening in Taiwan. So these are the floods. A very, very serious typhoon invaded one of the county in Taiwan and create lots of things. But as you can see, it's been already lots of things we'll be able to do, like if we need to shut down the roads in advance, if we need to put the pumper here. So nowadays, because we've been learned a lot of things, and also in a city itself, not only by the 4G, but most of the telecommunication company in Taiwan, they all create some kind of MBiot. So MBiot is much cheaper way of the communication. So if we have the some kind of rain gauge, and also we have some kind of sensor to detect the water level in each manhole cover. So which means the drainage, even for the side ditch or the rainfall sewage systems or everything, then we can reflect the real condition of that moment. And also we have the rainfall gauge, we have the water level gauge. So we'll be able to tell the entire story in real time. And also we have the camera, the surveillance camera, and the camera will be able to make some kind of image recognition by telling if this place has been flooded or not. So we can do a lot of things. And we can use the forecasting by the Central Weather Bureau. They send out the forecasting things. So we can be prepared. We can be scheduled. So, and also we can use this kind of detection dashboard. This kind of dashboard requires a lot of things. In Taiwan, some of the metropolitan city government, they already create this kind of dashboard. This kind of dashboard is automatically record lots of things. It records like if there's water level, if there's any kind of sensors, the flooding sensor, the hydrograph, or the sewage water level. It knows about the drainage, about the water level, about each ditch, about each sewage system, where has been flooded, or what will be. And flood detection, after each, just put on each manhole, and it can automatically send back all the things. All these kind of things is already being applied in some of the major cities in Taiwan. So all these kind of sensors, it send out the information about the water level directly using the MBiot communication technique. And it can use a very small battery. And also in the outside, it can use some kind of very simple solar panel to get the power. So it's not necessary to change the battery every month or every day. No, you just need to change the battery probably just once a year. So nowadays, all these kind of sensors has been developed because in Taiwan, there are lots of manufacturing factories and there are lots of researchers and academic researchers. They develop very, very good chips. And using this kind of very, very good device, we'll be able to identify a lot of things in very easy way. So use this kind of dashboard. We'll be able to just in one platform. For example, just in this platform, we'll be able to tell where and what is happening now. And using all this kind of information, we'll be able even to track about the previous things. Like this is like on real one, and also we can track everything because we have the monitor, we have the camera, and we have all the water level, and we can have all the module to analyze. So there are lots of things. The government knows, do we need to send an alert to local city government, or do we need to send some kind of pumping device into the site in advance? So all the camera and all different kind of sensors is become smarter and smarter, just like human brain. Because everything will be able to learn just by all this kind of learning scale. So using this kind of algorithm is become smarter and smarter. So even by the reason of the floods, or the training sample, everything, and all the issues, and we'll be able to streaming all the images directly through a cell phone. So everyone can receive some kind of like warning signal or warning message just using his cell phone. So it gets very, very smart and easy to use. So this has already been applied in some of the city in Taiwan. So this is one of the reason, like for this afternoon, for this course about disaster management, I would like to emphasize not only by the sensors, but also by the domain knowledge about knowing what means by the reflectance of the sensors. And we can have some kind of very good artificial intelligence. We don't need to be a very good expert in the future in knowing everything, but we can use the kind of already being built up everything inside the sensor, inside the kind of facility, and everyone will be very easily to use the cell phone or to receive any kind of warning system to the specific person. For example, if I'm close to some kind of like, it will happen for a very, very high, extremely large, the rainfall amount being forecast. So only the area, who is in this area, they will receive some kind of warning signal saying, okay, you have to watch out for the next 6 hours. There will be very, very high precipitation amount. There will be very, very, very high rainfall. Suggest you to go to some higher place or suggest you to make some kind of preparation. And also the government can make some kind of good preparation because as I mentioned about, nowadays it's impossible we can use all the engineering construction way to cope with the nature disaster. We'll not be able to make the return period is 500 years in any city. So, but we are jumping into the kind of 300-year return period or 500-year return period of the rainfall. So the only way to cope with that is the resilience smart city, which means we still need to suffer about the damage caused by the earthquake, the damage caused by the typhoon, but we'll be able to make good preparation. We'll be able to reduce the possible damage. We'll be able to be recovered very soon. So that's mean the resilience. Let me show you what I mentioned about the artificial intelligence one. For example, this is one of the camera being stored in one of the county in Taiwan. And the camera itself, it will be able to identify this is the floods and this is the boundary of the floods and that is the truck and that is the motorcycle. So because it learned by the deep learning algorithm. So it learned by the originally, we have to teach the camera to learn about this is the area, this is the boundary, this is the person who riding the bicycle, this is the truck who passing by, and this is the splash of the water. Then you can count the depth of the floods. So you can even count because of the different color of the water being splashed by the tire, by the vehicle's tire. Then we'll be able to identify the possible depth of the floods. So that's how we try to train the local camera. So the local camera become a very, very smart device. So it knows when there are floods, and how about the depth and everything. So we have to let the camera learn everything by some of the previous images then the camera itself becomes smarter and smarter each time because it can learn even by itself. So it learned by how to use this kind of things, this kind of sensors. For example, this is also the dashboard for the Taoyuan County in Taiwan. And as you can see, this is one of the camera. And we have all the different kind of like the rain gauge amount or the water level or everything along the entire area. And also for the camera will be able to identify like what about if there are floods and also about the flood depth. So it can automatically identify like now it's gradually because from the upstream there was a very, very high precipitation. So it's possible here will have some kind of, we say, floods problem. So now all the sensors and all this kind of sensors reaction, it can publish, it can communicate just by the same kind of standards. So that's why I said the international standard is very, very important. For example, like this one. In this camera, the image of this camera, as you can see, it can identify like the splash of the water. So it identifies the different color, and also it knows because this is a normal car. So the wheel, it can identify about the water changes and tell just by the camera, the water depth of here is 11 centimeter. And how we can prove that? This is a virtual scale. It's not exist in the real world. It's only embedded inside the camera. So inside the camera, it knows use this kind of scale, a virtual scale. It knows exactly what's the depth being merged inside the water. So this is a virtual scale. This is also one way to identify about the water depth during this moment. This is another facility. The Taoyuan City government, they put this kind of flood depth, we say detection sensors. So inside there's some kind of scale. So this detection facility can really count the real flood depth in very, very accurate way. So by these three things, we try to have this image to learn by the splash of the water changes. So this image becomes smarter and smarter. So as here, you can see from 11 to, so this is how the image can learn by itself. So it identify like there are 11, there are 12, there are 13 centimeter of the floods by different tires. So it's getting an average. We can say here, we know exact the first steps is about, is only average is about 10 centimeter. And the way we have this camera become smarter and smarter is because we have the virtual scale and we have the real facility, the real sensors here. So those two things try to help this sensor. So this camera in the future, there's no need for this kind of virtual scale. There's no need for the real sensors. It needs just this image. Then the image is smart enough to identify about the area, identify about the flood depth. So this has been already been implemented in some of the cities in Taiwan. And because sometimes it's too hard to really measure, to really detect the real-time flux area and flux depth. So once we have very, very accurate flux depth, flux area, we'll be able to know what we should do next time to avoid this kind of things happening. Like if any kind of ditches, any kind of drainage system can perform a better way, can perform even more efficiently. So for next time, we can try to avoid this kind of things happening again. So this is what I say a very smart device. And also in Taiwan, we try to have all this kind of sensors to learn by itself. So for the past probably 5 years, there is a very good technique being developed. It's called edge computing. What means by edge computing? It means all the sensors become a very intelligent sensors. Previously, you have to have a person to watch, to really use his own eyes, to really watch all the different kind of camera or video and to find anything being strange. But with the edge computing, all the camera on site, if it's equipped with some kind of powerful hardware or chips, and there already been some kind of algorithm has been embedded inside, then the camera become a very smart one. It can really tell you, for example, like this one, the camera, it will reflect to you when the camera detects something strange, or the camera detect there are already the flux depth is over like 15 centimeter, then this camera will automatically reflect to you. Or you can set the threshold. So this is what I mean by, if we want to do a very good disaster management, the first thing we need to know is what is happening now. Of course, a lot of good scholars, a lot of good researchers, they can make good equation, they can make good model, they can make very, very good algorithm to predict some of the major disaster. But technically, nowadays, we can make very good rainfall forecasting. But for other things, it's still underdeveloped. So lots of things, even for the earthquake or some kind of landslides, we know there are some parts has very, very high risk of the potential landslides, but it's really hard to really predict it. But hopefully we'll be able to really predict some things in the next 10 or 20 years, because we try to learn, because we have all this kind of information. But the most important thing is all the sensors, they have to communicate with each other. And also all the agency who puts different kind of sensors, they have to work together. Interoperability. That means we need to exchange all the information for the past and for now, and also for the future. So the good thing for a smart city is all the people inside, they have to work out together, and everyone needs to work out together because of the interoperability. So what we do, try to learn about this is, for example, this is just to use a cell phone, and you can identify lots of things just directly by the cell phone. You can identify by the catalog. So the cell phone will be able to recognize what the image mean. Not just so the cell phone itself, it knows, okay, this image is telling this is Uber Eats. and this is a two-person with a kid, and this is a car. So in the future, there are lots of things. There are lots of things we'll be able to learn directly just by the cell phone. So image collection and model analysis and image training platform is all very, very important things. So in Taiwan, all the governmental agencies and private sector and also researchers in the university, we all try to work out together, and we all try to make easier and also make artificial intelligence for different kind of sensors or detectors. So instant report of the flooding events is also possible because of all this kind of camera can become a very, very good, a very smart device. So the camera will be able to make a report by itself. So you don't need anymore to have any kind of person to track back all the images, all the camera. But you can have some kind of artificial intelligence embedded inside the camera. So the camera will be able just making some kind of flooding events report by itself. It looks like just in the movie, you're watching some kind of Terminator movie or some kind of very, very smart artificial intelligence movie, but it is possible now. Regarding the disaster management, it is already possible, and it's already being implemented in some of the metropolitan city in Taiwan. Because some of the central government or some of the city government, they already use this kind of very, very smart or intelligent system. They can identify lots of things directly. And some other images, for example, I'll use, these are some of the other images being created. For example, the flooding recognition, have the camera to learn about itself, to learn by itself about the flood area, the flood depth, and also the camera will be able to identify how many people went through the gate. Even on my campus, a team of the students, they use the camera and they can identify on the campus there are several ducks. And using this camera, they can very easily count how many ducks are there and where are they going to and how many hours they spent near this pond. And also lots of things. Like before, we can very easily identify about the car plate number, but now we also need to track about the vehicle model. So there are a lot of things we'll be able to identify. For example, like we need to identify about the reservoir water level. As you can see, there's no green line. It's being identified automatically by the camera itself. So the camera knows what is the water level now. And also it can compare with some of the recorded thread. So like this kind of green color and the red color is not exist in the real world. But the camera itself, it can identify this is with water, this is without water. And this is a virtual scale. If the water level being arise, so this virtual scale will be emerged inside the water. So you will know what is the water level now. If it's in danger to the breach, do we need to shut down of the breach? Or how about the water reservoir? Inside the water reservoir, the water level, it can automatically identify. So a lot of these kind of things, all this kind of facility, all this kind of sensor can become smarter and smarter. And all the things, they can communicate with each other. So that's why we say Internet of Things. Let's say IoT. because Internet of Things means every sensor can communicate, every sensor will be able to tell the entire story. It can even make its own report, just like this one. It can make its own report. If there has been any kind of floods, it can make its own report, and it can inform any manager who need to know if there are any kind of things happening. So if there's traffic, if there's a kind of like construction failure, if there's a crack, if there's any kind of movement, it can automatically inform whomever needs to know. So this can create, we say, a smart city. So the smart city is based on lots of this kind of Internet of Things facility, lots of this kind of work together, collaboration, because it requires a lot of different kind of domain knowledge. You need to know how to make edge computing by the sensor. You need to know how to develop a sensor, a cheap one and durable one. Especially in Taiwan, lots of the field sensors, it require a very low power supply, or even the power supply from the solar panel. And so there are lots of things. There are lots of things we need to use this kind of very, very smart sensors. So the image recognition solution, the GIS with the AI, I think that's the image recognition solution. Using this kind of things, we'll be able to identify a lot of things directly by the camera. Not only about the landslide, but also about the floods, and also about lots of things. Even we can use like this one. You can use the AR technique just inside the cell phone. For the navigation, we can use the AI as navigation through the real world. So using this kind of image recognition solution, and all the sensors become smarter and smarter, and the entire city can be a smart city. So all these kind of things require lots of things. So today I talk to you about how the examples in Taiwan's by the central government and also local government, and also lots of private sectors and university scholars work together toward this kind of disaster management, because we suffer by earthquake, we suffer by typhoon each year. So in Taiwan, there are lots of very, very good devices being developed. For example, like remote monitoring system. So lots of like company can provide this kind of facilities. A very compact one and very portable one. Just put this kind of facility in any kind of site. It can automatically record everything in 24 hours. It can send back all the feature. And also inside, it can be very smart, because you can tell, you can let the image learn by itself. So you can put some kind of AI technique by yourself. You want the camera know, okay, this means the crane is digging the kind of construction. This means there's something happening here. So the camera will become smarter and smarter each time. And the entire facility is very portable. And you can use different kind of communication device. If they're 4G, use a 4G. If they're Wi-Fi, use a Wi-Fi. If they're MBiot, use a MBiot. They're LoRa, use a LoRa. So it can receive all different kind of communication facilities. So to do the remote monitoring system. So in Taiwan,
easy to know disaster prevention
there are lots of things happening.
In the beautiful and sunny weather, Bao's family participated in the community's natural ecological guided activity.
So this is one of the video we made to the Department of Fire in the Ministry of Interior.
Will it rain heavily? The sun is bright now. It is not supposed to rain. And I checked the easy-to-know disaster.
This is what I mean, the
website.
easy-to-know disaster.
The weather forecast says that the weather in the mountains is sunny. Don't worry.
Please come here to join the mountain hiking ecological tour. Please follow me and my instructions. The weather in the mountain changes greatly. I will focus on the weather and rainfall forecasts at all times. If the weather conditions are bad and we need to evacuate, please cooperate.
No problem. Safety first.
The streams in Taiwan have a diversity of ecosystem, but the streams also have dangers.
Why is it dangerous?
The streams in the mountainous areas are short and rapid. That is easy to cause the streams to swell and flash floods when raining. If we do not pay attention to the weather and rain, we might be trapped or washed away by the floods.
Suddenly, the sky was covered with clouds. It looked like it's going to rain.
Don't worry, I have subscribed to the real.
So this is one a very popular API already being used in Taiwan by the Central Department of Fire. And also each metropolitan or city government, they also developed their own API.
To hide from the rain. I will continue to explain to everyone later.
You also know the easy-to-know disaster prevention website?
Of course. As a professional guide, grasping real-time weather and disaster prevention information is an indispensable skill. Transform! Disaster prevention expert.
So this is one of the API. The Fengjian University being worked together
is the disaster prevention and evacuation system
with the National Fire Agency.
It provides daily life information, disaster warning, evacuation instructions, and disaster prevention related links that we often need to know in our lives. You can even know whether it will rain in the next hour. The homepage can also adjust the information displayed on the homepage favorites according to the content you need. In the event of heavy rain, typhoons, earthquakes, and other serious disaster, easy-to-know disaster prevention website will automatically broadcast disaster warnings, allowing you to grasp a full range of disaster prevention information. The evacuation map is also a very useful function of easy-to-know disaster prevention website.
So this requires lots of like GIS technique and also a lot of information being published by different central government.
The evacuation map will display the detailed information of these locations on the device. As long as the evacuation map is stored in your mobile phone, you can view and share it with friends and relatives at any time. In addition, easy-to-know disaster prevention website has a special area for disaster information, where you can view the disaster information of each disaster, as well as the government's emergency response situation. And you can grasp the latest information of disasters at any time. Directly search the easy-to-know disaster prevention website. Enter the website pear.emic.gov.tw or just scan the QR code. Become a disaster prevention expert with me.
Okay, so this is one of the system from the university being worked together with the central government. So this is something I mentioned about for the disaster management in Taiwan. There are lots of things are happening. There are lots of different kind of projects are happening. So that was made by the Fengjian University with the National Fire Agency, and also for the IoT water information platform is also by the Fengjian University with some of the city government. For example, one of the city in Taiwan, there are 60 rainfall stations, 155 the flooding monitoring stations, there's 65 regional drainage water level monitoring station, there are 125 CCTV camera, there's 60 rainfall sewage system station, there are 90 sewage sewer monitoring station, there are 9 water gate remote control station, 6 pump monitoring station. everything has to be communicated with each other. So the only way to make it workable is through the international standard. And also the government will be able to remotely control everything in real time. And this is already being implemented in one of the major cities in Taiwan. So all the information by different sensors can all work out together and all can all communicate with each other. And the platform itself is very easy to get very good management. So this is what I mentioned about in this afternoon session about how to make the IoT smart and what we mean by the smart city. Because if you're capable to call as a smart city, you have to know in advance, you have to know in real time, and you have to learn by each event. So as we say, the smart city. So in Taiwan, there are lots of platforms has been developed, lots of, even for the river and drainage management system to maintain a sustainable environment, for the patroller to make some reports, suspected, everything. So there are lots of application has been widely used in Taiwan, not only towards some kind of nature disaster, but also if there are car accident, if there is construction failure, lots of these kind of things. It can very smart and reflect all the things in the real time, in the real side. So for integrated platform, there are lots of very good application will be able to adopt it due to this kind of good domain knowledge and very, very good development of the Internet of Things and also the artificial intelligence. So lots of this kind of domain knowledge and use this kind of like sharing together the information in a three-dimensional way to represent all the real information. There are lots of things. It's become possible to make a city smart. So as a smart city, there are lots of things. We have to work out with each other. For example, in Taiwan, there are very, very serious fire. So very serious like local like building fires. It all causes a lot of damages. So if there any way, just like we learned by the nature disaster, if there any way we'll be able to reduce or to get good recovery by each incident. So all the agencies have to work out together. And it is possible if we have very good information toward each building, toward all the different kind of material and to analyze and use the historical information and also the real-time information, will be able to reduce the possible of the fire risk. So we say in the future, as a smart city, it's all in one strategic information platform. Everything is just use one platform. For example, now, even to create this kind of report, it's very easy, use Power BI software. So the software today is much, much easier now. So easy to produce the software, easy to produce the kind of readable or for any human being. And also is good to communicate with each machine to machine. So this sensor can communicate with the other sensor. The upstream sensor will be able to send a warning information not only to the local resident, but also to another machine, to another sensor, to have another sensor to double check it. So that means by the artificial intelligence. So it can use in so many different aspects, so many different ways. So this afternoon I talk about a nature disaster, but even for the water resources, we'll be able to know about the reservoir condition, everything, not only the water quantity, but also the water quality, or even air pollution. So lots of things, how you can manage your land, how you can zoning about the future land development. You can use the same kind of ideas, same kind of platform. So as this afternoon, so this is the end of my lecture for this afternoon. For the disaster management, we learn a lot of things that we know towards successful smart city. The research and development and marketing has to work together. Then only through the open, because lots of data has to be open data. Everyone has to share the data and also use good sharing. And of course, the communication is a very, very important one. So the cooperation across the industry, academy, and also the government, it is possible we can make all the things as a value-added services. And through the intelligent, through the service, it's a smiling curve. So I think toward a smart city, it is a very possible way through a lot of this kind of Internet of Things or artificial intelligence. So, okay. So this is the end of my lecture today. I hope everyone will be able to understand more about how we can apply the artificial intelligence and Internet of Things toward a smart city and using the GIS, using the remote sensing technique, and also be collaborate with each other. Thank you. So our
Thank you, Professor Chou.
yeah, so I'll get a control back.
Okay, waiting. I show my screen.
Okay.
Okay, can you see that?
Yeah. Okay, thank you. So
Thank you.
I think the Taiwan Space Union they were inform everyone like about the quiz and also the QR code, and also they will have questionnaire to ask about your opinion. Hopefully we'll be able to improve each lecture by each lecture, and hopefully you enjoy the course. So once again, my name is Tien-Yin Chou. So this is the second course of mine. So I'll have another course after 2 weeks. So hopefully you enjoy the entire series of this course being designed by the Taiwan Space Union. Okay, bye-bye.
Thank you, Professor Chou. you.